We always hear about tectonic plates, right? How they crash together to build mountains or pull apart to form oceans. But there's a third way they move, this kind of weird sideways slide. Well, today we're going to dig into the geometric secret that, believe it or not, holds the entire system together. So here's the big question. If plates are all about creating new land in one spot and destroying old land somewhere else, why do they also just slide sideways? It feels like the odd piece of the puzzle. It just doesn't seem to fit the whole creation and destruction story. Okay, so let's lay it all out. You've got your mid-ocean ridges. Those are the factories, right? They're creating new crust. Then you have ocean trenches, the recycling plants, destroying the old stuff. It's this neat balanced system. And then you get to transform faults. What do? Well, they don't create, they don't destroy, they just slide. They're the weirdos of the plate boundary world. So what on earth are they even for? Okay, let's put on our detective hats. The first major clue in this whole geological mystery is actually pretty simple. It's the shape of our planet itself. Turns out the real problem isn't the plates, it's the playground they're moving on, a giant sphere. So think about this. On a totally flat surface, say a big table, geometry is super straightforward. If you draw two parallel lines, they can go on forever without ever meeting. Easy peasy, right? Yeah, but try that on a sphere, and it's a whole different story. They can't stay parallel. That simple little rule just completely falls apart. I mean, just look at a globe. The lines of longitude, they look parallel down at the equator, but trace them up and boom, they all smash together at the poles. And that exact same problem is what our huge, rigid tectonic plates are dealing with every single day. Okay, so let's bring this abstract geometry problem back to the real world, to our planet. You've got these mid-ocean ridges, and they're just constantly churning out new crust, spreading apart. And here's the kicker. They're doing it on a curve. So the direction they're pushing isn't the same everywhere along that ridge. One part is trying to go this way, another part is trying to go that way, and it creates this massive mismatch. All that conflicting movement builds up an absolutely incredible amount of stress in the crust. So what's a planet to do with all that built-up tension? Well, Earth has a solution. It's kind of violent, but also really elegant. It just tears itself sideways. Here's a great way to picture it. Grab a piece of paper. Now try to tear it in two parallel lines right next to each other. See what happens? You can't do it cleanly, right? It always rips sideways between your two tears. That's the paper's way of releasing the stress, and that is exactly what's happening to Earth's crust on a massive scale. The crust just can't handle being pulled in slightly different directions, so it rips sideways. And that rip? That's our transform fault. It's basically a planetary pressure release valve. All right, so we've got our theory. The planet rips sideways to let off steam. But a theory isn't enough, is it? We're detectives here. We need to find the evidence, the fingerprints left at the scene. So what should we be looking for? The most fundamental clue is the motion itself. It's just one plate sliding right past another. That's it. There's no up and down, no pulling apart, no epic collisions. It's pure, simple, horizontal movement. And if you need another way to picture this, think about two giant conveyor belts right next to each other. But here's the trick. They're moving in opposite directions. That line where they meet, that zone of pure friction and grinding, yep, that's your transform fault in a nutshell. And this, right here, this is the smoking gun. This is the key piece of evidence that cracks the case. First question, do you get earthquakes at these faults? Oh, you bet. All that grinding and sliding builds up friction, and when it lets go, bam, earthquake. But, and this is the big one, do you get volcanoes? Nope, not a single one. And that tells us everything. Volcanoes mean magma is coming to the surface, which only happens when you're creating or destroying crust. The fact that there are no volcanoes here is rock-solid proof that nothing is being made or destroyed. It is purely a sideways slide. Okay, so let's recap our investigation. We started with a geometry problem, moving on a sphere. We found the Earth's solution, a sideways rip, and we just looked at the evidence, earthquakes without volcanoes. All the pieces are on the table. It's time for the grand reveal to put it all together. And it really boils down to this single, powerful idea. Transform faults aren't just some random geological quirk. They're not an accident. They have to exist. They are the direct, unavoidable result of two basic facts about our home. One, it's a sphere, and two, its plates are moving. So this totally changes how we should think about them, right? They're not just cracks, they're a fundamental part of the machinery. You can think of them as the geometric connectors, or even better, the hinges that allow these massive, stiff plates to actually move around a sphere without everything jamming up. Yeah, exactly. They're like the seams in a perfectly tailored suit. They're what allows the fabric of the Earth's crust to move and flex smoothly. Without those seams, the plates would just get stuck. They'd lock up, totally unable to handle the curve of the planet. It's such an elegant solution to this huge planetary scale geometry problem. So, okay, we've gone through this whole detective story, but what's the bottom line? Why should you care about this? What's the big takeaway here? It all comes down to one simple, profound idea. Transform faults aren't weird, they're necessary. They're the planet's absolutely brilliant built-in engineering solution that lets these giant, rigid plates move across a curved surface. Without them, the whole dynamic engine of our planet would seize up and grind to a halt. They are, quite literally, the geometric hinges that allow our world to work.